Okay, so that's what I'm missing out. You didn't tell me that it had other authentication methods. Okay, that's an important.
Okay, we're going to get started in 1 minute, guys. So if you're here for PCE, then please sit down. If not, then we're about to start PCE. Welcome to PCE. So I'm John Hardwick. Unfortunately, Julian and JP, neither of them could travel this time to South Korea, so I'm going to be ably assisted today by our working group secretary, Dan King. He's sitting in the co-chair seat. Before we start, please familiarise yourself with the IETF note well. Anything that you say or do during the session is considered an IETF contribution, and if you have any IPR on any of your IETF contributions, please declare it. So to cover the administrivia, we're going to be doing live streaming via Meet Echo as usual. So please speak only using the mic, and please state your name before you speak. And if you're presenting, please could you stand inside this little pink box down here so that the video can see you. We are going to be collaborating on minutes, as is the new tradition, using the Etherpad. So if you could find the link to the Etherpad on the IETF agenda for PCE and get yourself in there, you can help us all take minutes. I'd like to see plenty of people helping out so we get a good set of minutes. Is anyone in the Jabber room? Okay, great. If you guys could keep an eye out for people wanting to make comments via Jabber and bring them to the mic, please. So splash the agenda. So this is slide 1 of 2. Slide 2 of 2. Hopefully I got everyone who requested the slot. Anyone want to bash the agenda? No? That's good. Okay. also to take you through the current working group status. Oh yeah, before we take you through the current working group status, this is the reminder that we always put up before we start the meeting. Please use the mailing list for PCE. We know that people do discuss items, issues off list, and that's fine. And people, will make changes to drafts without there being discussion on the list, and that's fine. But please do bring those discussions to the list and let everyone know what's going on, so we can see what's happening behind the scenes. Otherwise, it's kind of hard when there's just continued radio silence to know how much work's going on and who has been contributing. So please use the mailing list. Okay, so since our last meeting, we have no new RFCs, but we do have 2 documents in the RFC editor queue. The first one, remarkably, our first stateful PC RFC, the PC stateful PC applicability statements. Well done to Xian and Ina for getting that document over the line. Also, the PCEP service aware draft, well done to Drew for getting that in there. That's currently stalled, waiting for the base PC protocol to be published, and then that will be given an RFC too. We have early code point allocations from IANA for 4 of our drafts, and it would be really good not to have to run into renewal issues with those allocations. So please could the authors of those drafts, and I include myself in that because I'm the author of 2 of them, get on with it so that we can put those to rest before we have to, before we hit IANA problems. Adrian.
Adrian Farrell. John, what did you mean on that slide by no renewal, exclamation mark?
No renewal. Good question. So standard IANA rules are that you make an early code point allocation for a period of 1 year, after which you're allowed to renew once for a further year, and then you're not allowed to renew again unless you have special dispensation.
That was what I was after, the special dispensation that can be given by the area director. So no renewal, as I read it, means that's been withdrawn, or what?
We can ask the ISG to renew, right,
Yeah.
after that period. But I didn't really want to say anything, Adrian, because I really hoped that it was there more as a prodding from the chairs to get the documents done. Right?
That's correct. I know that
so-
avenue exists, but I don't want to use it.
Yeah,
It'd
we
be
don't-
kind of disappointing to have to do that.
And now you've stimulated me. These documents, right, I want to see them published as RFCs. I am expletive annoyed that they are not published as RFCs a year ago. Can we please, working group chairs, authors, get these out? And I, as a participant, I'm completely stuck. I have no lever to make this happen. Please, can somebody make it happen?
Okay. Thank you. So I would echo that, and I'll say a few more words about it in a moment. So we have a bunch of drafts which are post-working group last call. We have recently last called these 2 on the screen. One is the Intel extension draft, which during last call, Adrian, you made a bunch of comments on, and then marked up your own comments. And then I think Drew sent some more comments. And I'm a little unclear about what the next step is there. So do the authors want to make a comment about what's going to happen with this now? Drew, you look confused? No? Okay, so I'm going to be sending an email chasing those authors to please reply to Drew and either make the further markups or say that we're not going to, so that we can move that on. Inter-area AS applicability, passed last call with 0 comments, so I assume it's perfect in every way. So it's just pending a Shepherd's report, which I will knock out as soon as we finish this IETF meeting. All right, so the contentious expletive ones. The stateful PCE draft is still pending a markup because of an issue raised on the list. Since I wrote this slide, actually, we've had contact with the authors, none of who are here today, but I've been told that the markup will be made within a date of 1 week. Once that markup's made, we'll be pushing it into the IESG. Okay, so that's hopefully good news for that one. The PC initiated LSP, I think, is stable and is ready to go along with the base draft. There's no point pushing that on until the base draft is there. The stateful sync optimizations, again, is ready to go, and we're just waiting for the base draft. So hopefully all three on this slide will be pushed forward to the IESG within a matter of a week or maybe slightly more than a week. And then the final two, PSAP-S and the GMPLS extensions. I think these are waiting for cycles with the assigned shepherds to get them progressed. So sorry for the delay. I'll try and work with the other shepherds to get those moved forward. And then that leaves these two in the queue for last call, the RWA extensions and the hierarchy extensions. I intend to last call them in that order. And I'll get those last calls out after the IETF meeting finishes this time round. Which leaves us with a set of 9 other working group drafts, none of which are on the agenda for today. So I don't think any of these are yet being requested for last call. Has anyone got an update on the status of any of the drafts that they are currently authoring?
Hi, Dhruv from Huawei. First, the last document was never adopted. I think it was a mistake. This interdomain LSP for stateful PCE, I think by mistake we got adopted. It was given as an individual draft, but put it as draft IETF. So I think that's one mistake. So we are at least one down. And we presented the Yang in the PC, the joint session. So that's progressing well. I have a P2MP draft on agenda, which will have an impact on the stateful P2MP as well. So I can discuss that during my time. Thank you.
Okay, I'll see if I can make that final draft disappear from my list on the data tracker so that no one gets confused again. Okay, and that's the status. So I think the first speaker is Dhruv.
John. Hi.
Oh, Himanshu.
Yeah, I have there's one individual draft that's not being called for the working group adoption even after a couple of requests. I want to draw your attention to that. That's the one with the auto bandwidth. We have interest in that. I think that there are some implementations. So I request that working group, it's adopted for working group, or at least called for that.
Yeah. So does anyone in the room want to second Himanshu's request or want to speak out against it? This is the auto bandwidth.
Yeah, I think Rakesh and Dhruv are the authors on that. So you want to second that adoption? Yeah.
Okay, so a bunch of the authors are sticking their hands up saying yes. Anyone else? No one seems to be bleeping out of the seat saying no, that's a bad idea. I think the sticking point has been that JP had some significant concerns about the document, and I know he sent an email. I don't know where that thread got to, but I didn't hear back from him, and frankly, I don't know at this point what would be stopping us from calling for adoption. So,
Dhruv, so we replied to JP's comment, and at least on the mailing list, we thought that it's been closed, and I think we can discuss further how to move this document further. We are ready to make any changes that the working group would like. We would want this to be adopted. We just want to tell us what change would you like for it to be called to adoption, and we'll do it.
Okay. Thanks for the reminder on that.
The placement isn't that great. Let me. Okay. Okay.
You have a clicker?
Yeah.
Yeah.
Hi, this is Dhruv. On behalf of my co-authors, we are going to talk about associating policies with LSPs. And these are the set of authors that have come together for this. So the idea is pretty simple. We would like to associate policies to a group of LSPs and extend PSEP to carry this information. And some of you may recall that this has been discussed a couple of times. There has been different version of this document before. So we authors have come together and tried to consolidate and come up with a converged mechanism that we all are agreeing on, that we already have a generic association mechanism. So if we can use the generic association object to meet this policy requirement, that would be the best way forward. So what is the requirement? The requirement is straightforward, that we would like to associate LSPs with a policy, and we don't want the PSEP protocol to carry the policy details. So policy is basically just an opaque identifier that the two PSEP peers need to agree on out of band. So we would like to do that because this will simplify network operations. We don't have to do actual protocol updates, and new policies can be added much faster. Some of the ideas of policies that we have help in path computation when we would like to modify the computation and simplify or decide which constraints should be relaxed, how the diversity or optimization should be applied. These kind of parameters we can apply during path computation using policy, as well as when the path is set up. If you want to do path monitoring, some optimization and other things, we can do it via policy association. And we hope that this is applicable for both stateful and stateless PCE. So association object defined is right here. It has an association type, association ID, and the source, and bunch of optional TLVs, which were discussed when we adopted the generic association draft. So what we do here is just define a new type, and that type is the policy association group. And within this type, we allow a TLV for vendor information as well, which is the vendor information TLV. So any vendor specific behavior can be carried inside that container. So what happens is, basically, when your association type is policy, you have an association ID and a source, which will uniquely identify a policy at the two PSEP peers. Some use, basically, in case of once you have initiated the PCE, you want to enforce a policy at PCC, you can carry this association object, carry the parameters, and the PCC will figure it out what it needs to enforce. Similarly, via request and reply, you can have some constraints and other mechanisms specified here. The two PCCs use this policy ID Y to uniquely identify what behavior you would like these two LSPs to be policy to be applied on these two LSPs. So it's pretty straightforward idea. The differences in the previous draft were only between how do we encode, how do we carry this. So all the authors have sort of agreed that we can use this generic association as a way to achieve this use case. So this is a useful feature. We have operators who are asking for this. We are reusing a generic mechanism which the working group has adopted, and even implementations are pipeline. We will also wish the generic association to be standardized soon so that we can use it. So comments? Okay.
It's Adrian. Yeah, so sorry, I've not digested this, but what just entered my head and I couldn't grep fast enough was how this relates to the signaled policy that RSVPTE might use, whether you would consider that there's I understand a vendor specific, but whether there's also a vendor independent mode that you would want. So you would want to allow the vendor information TLV, and you'd also want to allow an RSVP compatible policy TLV.
I think it's definitely possible. And I'll work with you to figure it out how we can add that. Do you want to add something?
No,
No.
I'm the next one.
Next presentation.
Okay, thanks, Drew. Stefan.
Okay, so first draft, I'm Stefan Nikowski, working from Orange. So it's another association group extension for past diversity. So what we want is to give the ability for a PCC to signal a particular disjointness constraints, especially when the two LSPs are starting from different headends. So we are simply reusing the association group like for the policy, and we plan to define 4 different association types, one per type of diversity that we want to achieve. So we can think about link disjointness, node disjointness, SRLG disjointness, and node plus SRLG disjointness, which is one of the famous one for our customers. So this is really basic. So we are using the association type and association ID as a particular identifier to for this association. In addition to this, we would like to be able to drive the disjointness computation behavior with some part of a standard way. So we are proposing a new optional TLV, so the disjointness information TLV, that is currently carrying 2 interesting flags. So the first flag is what we call the S flag. So it will be set if the customer wants a strict disjointness. So if the PC is not able to find disjoint path, there will be no path, at least for one of the LSP. And the other interesting feature is to force one of the particular LSP on the shortest path, because there's sometimes customer wants to have one of the paths to be really optimal and the other to be used as backup. So, and if you apply a very generic disjointness computation, you may fall into a situation where both paths will not be optimal. So we have a flag to tell that this particular LSP must be on shortest path and the other one must be disjoint, whatever it's longer or not. And we can still use the vendor information TLV to encode whatever specific information for vendor. So we are welcoming comments on this proposal, but it's really straightforward. We have some urgency in terms of implementation. So we already have some running codes from some vendors. So we would like this to be standardized as soon as possible, especially to ensure the code point allocations that we are using. But as a first step, we absolutely need to close the base association group, the draft. So the author of this draft should speed up to close the work, and then we can also run to the early allocation process. So we would like to go to the working group adoption for this draft. So if you have any question now, feel free.
Hao from Huawei. Actually, I reviewed this document and find it is a very useful scenario, and I agree that the working group should work on this. Actually, I would also like to remind that we did have a kind of similar job maybe 1 or 2 years ago. We call that a resource sharing object, which is highly related with this kind of disjoint path computation, or try to share the resource, which is another extreme. So I would like to ask for work together and discuss this.
Yeah,
okay.
Sure.
Thank you.
So, Loa Anderson, can you go back to the slide with the flags? Okay.
This one.
Yeah. I thought, thinking about the shortest path flag, is that the strict shortest path? That might be the reason why you can't use that one, for some other reason. So if you have Is that
It's when we mean shortest path, it's shortest path based on the constraints that are also used for this
so?
LSP.
It's a contextual type of shortest path. It's not the lowest hop count you can.
Right, right.
Okay.
I have a similar clarification question on shortest path. Is it like a maximal disjointedness from that set, the shortest path in that, or when you're doing the shortest path, it is the disjointedness is not included at all?
That's right. You don't take into account the disjointness for one of the LSP. So the LSP, one of the LSP will have the shortest path flag set. So telling that the disjointness constraint will not be taken into account, but we will take into account other constraints, whatever it's bandwidth, IRO, XRO, or whatever. And then the other LSP will be disjoint, and you will use a non-shortest path that will be disjoint.
So if you said,
So you must have one path with S flag set, and the other one of the LSP with S flag set, and the other one is S flag 0. Otherwise, you will not be able to have disjointness at all.
and
Not sure.
if your shortest path doesn't allow for a totally disjoint path,
So you will not have disjoint path.
unless you
Be-
say it,
but this is
unless you
also
relax it and let it be maximally disjoint, right?
yes, but you can relax it using the strict
Yeah, right.
disjointness, where
Yeah.
you're able to fall back.
Yes, yes. I just wanted to clarify the behavior. It's
Yeah.
setting both bits or not.
Daniele, my question is pretty similar in the sense that I understood that those are two strict conditions. If one or the other is not met, fail. Don't you foresee something like, I don't know, I wanted to have them, like if you don't meet one of them, fail, or something, maybe another flag saying, you can relax the disjointedness and do whatever you can.
Yes, I see your point. We can think about this, but it will be harder to encode, I think, if you want to express interactions between the different constraints. If you want to relax, have some priority between the different flags, we can think about it, but...
Well, I would simply say, like...
but here it's strict, yes.
Okay, maybe add the two more flags saying relaxable, not relaxable, not relaxable.
Why not?
Okay, no, I was asking if you consider that or you don't want it.
We can think about it.
Okay,
yes.
okay.
Thank you.
It's Adrian. Yeah, on that point, just be careful of the difference between an objective function and this. So you might be able to put that. Anyway, I'd like to talk to you possibly offline about the difference between link disjoint and node disjoint.
Okay.
Lou Berger, have you looked at the LSP diversity work that's been going on it started out in CCamp, it's now in TEAS?
No.
So there's cool. That draft. Actually, I thought that was going to be it. That draft's been around a long time. It's gone through last call. I think it's it's pretty close to done. But there's a whole bunch of different cases that would be great to cover also in this.
Okay.
So take a look there and see if you can.
Thank you.
If you
can just send me the pointer.
Sure. Thank you.
So I had a couple of remarks. I think it's this is a good item of work because this is missing function. It's really needed. So yeah, I would like to put out a call for working group adoption for this. Remark as chair, I see that in the draft you've recommended the value for some TLVs in the appendix.
Right.
Please don't do that.
I understand.
So I think before we adopt, please could you submit a new version taking both recommendations out?
Okay.
If we adopt them, we can do the early allocation. That's a quick process.
Okay, we will do.
I had a question about the failure to compute disjoint paths by the PCE, but if it's not a strict disjointness, then the PCE can just return paths which aren't disjoint. Is that true?
you can implement multiple type of behavior. So for example, if you are requesting a node plus SRLG and you cannot find a disjoint path, you can fall back to maybe node only. And if node only is not working, you may fall back to link only. So you try to do a best effort, but it's a local optimization on the PC.
I think there needs to be some way to communicate back to the PCC the disjointness that was actually computed.
Okay.
Because otherwise the PCC will not know whether it got what it asked for or if it got something
That's
less.
true. Yes.
Okay.
Well, one more. So I think you just, Himanshu from Siena, I think you just touched on something I was going to talk about or ask about, is the preference. If you want strict SRLG, maximal SRLG, then node, then link. So based on what you can get the preference order, you try to get to convey that in that policy.
Okay.
If that can be included.
Okay.
Right. And then what John said is to relay back to what was used. Okay.
All right, we're going to switch the slides and Stefan is up again to talk about state synchronization.
State sync, yes. So it's a bit more complex subject. So we have an issue today with how the PSAP redundancy has been established in the base stateful PC draft. Because it's a very simple use case that has been described. And if we go to use some association group-based constraints, like, for example, diversity, we may fall into some issue. So that's why we try to enhance the situation to provide a better behavior. So first issue, it's not really an issue, but maybe not enough resilient scenario. So I have, is the pointer working? Yes. I have a PSAP topology, a transient PSAP topology, where one of my PCC has lost a PSAP session towards PC1. And due to the delegation, I have a kind of split brain scenario where one PC is computing for one PC is acting for one LSP, and the other PC is acting for the other LSP. And if, for example, I try to configure first an LSP from PCC1 to PCC2, so PC1 is acting for PCC1, I will use this ERO, so using shortest path here. And when I want to configure PCC3, PCC4 LSPs that must be disjoint from the first one, so PC2 is acting for the computation, but the disjointness requires to move the first LSP to find a room, and it's not possible there because the PC2 does not have a right to move the LSP because it does not have a delegation here. So it's not really an issue, it's more non-optimal behaviors that we may be able to enhance. The second problem is more problematic. If I use a similar PSAP topology, split brain topology, but all my PSAP sessions are up, and if I'm using such kind of topology, and if I provision my two LSPs in similar time frame, I may fall into a computation loop between PCs. So what happens? First of all, I provision my two LSPs. So each PC will compute a path independently of the other LSP because it's still not aware about the path of the other LSP. So both will use a kind of shortest path. So they are not disjoint at this moment. Then there will be a report. So each PC will be aware about the path that has been computed by the other one. And a disjointness computation can occur. So each PCE will compute disjointness based on this. So we will have disjointness. So that's fine. And they will report again. And as soon as they report again, they see that, okay, cool. There is some room to do a better computation with a more optimal path. So we will rerun a disjointness computation. And what will happen is that we are coming back to the first situation. Because of the topology I'm using here, the PC1 is able to use this link because the current state of the other LSP does not use this link. And on the other side, the other PC is also able to use this link because from a report point of view, the first LSP is not using this link also. So we have the computation loop because we have a gap between the view of the PC sent by the report and what has been really computed from a real-time point of view. So this is clearly an issue that we need to handle because it may crash some PCs or it will not be able to compute any more path. And the other situation that we want to improve is that from an operator point of view, we absolutely don't want to have a single PC cluster managing all the traffic engineering in the network. It will be no way because if there is an issue and if it crashes, I will have no network anymore. So we would like to have multiple PCs, clusters of PCs, maybe handling part of computation or whatever. I can do it, I can separate per AS, per area, or even in a single area having multiple PCs, whatever. So we need some communication between the PCs to be able to handle the scenarios. So how we are trying to solve the problem here? First of all, we need this inter-PC stateful communication. So we need to create a PCEP session between two PCs. So that has been done for stateless PC. For stateful PC, there is no working group document yet, or even RFC dealing with this. So we need to specify something. And for the other point, especially the computation loop, we can see that when I have some constraints-based computation, association-based computation, it's not really optimal to try to do this computation in a distributed way, because you may have non-optimal placement of the LSP, or you may have computation loop as I displayed. So the idea would be to, for a particular association, to ensure that a single LSP will always compute for all the LSPs of this association. So we would like to introduce a kind of master-slave relationship between the PCs. I'm talking about master-slave. It's not similar to hierarchical, by using a kind of sub-delegation mechanism. So we want to have the computation decorrelated from the PCEP meshing, in fact. So a PCC can be meshed to a set of PCs, but this set of PC may not be responsible for the computation. So how we do this? First of all, for the inter-PC PCEP session, we are introducing a new capability flag in the stateful capability TLV. And the idea is that both PC will act at the same time as a PCC and as a PC. So when the session is up, we will have bidirectional state synchronization. So today in the stateful PC draft, the PCC is sending a report and then via end of synchronization marker to the PCE. And here we will have the same, but in both directions. So they will synchronize each other their LSP database. And as soon as the synchronization is done on both directions, they can start a regular PCEP advertisement. So if there is some path, a new report coming from a PCC, it will be forwarded onto this PCEP session. And in case of this particular sub-delegation, I can use a PCEP report from one PC to another, setting the delegation flag to sub-delegate a particular LSP. And when the sub-delegation has been done, the receiving PC will be able to update and compute path for the PC, for the instead of the other PC. So that's the goal. So this master-slave behavior is based on a kind of priority mechanism. So today we are not dealing in the draft on how this priority is really working. It can be advertised maybe in IGP, BGP, or manual policy configuration. We don't really care, at least today. And what we want to build is a flexible system. So I want to be able to design any kind of scenario. So placing some association group computation on some particular PC, maybe some other scenario where I want to put all my LSPs computed by a single PC, or so I can do active standby or load sharing my computation. So it's really flexible. So if we go back to the computation loop issue, so what we will do here, so for example, is to elect PC1 as master PC. So PC2, when we will receive a report for the PCC3 LSP, it will subdelegate it to PC1 using a PCEP report with delegate flag 1. At this time, PC1 will be able to compute. So yes, so when PC1 receives the subdelegation, it computes the path for the second LSP. And as he has delegation for both LSPs, we have for sure an optimal placement and no computation loop can happen. So when the computation has been done, he is able to send an update for this LSP to PC2, and PC2 will forward this PC update to the PCC. So PC1 is also able to report the path that it computed for PCC1, PCC2. So there is a mistake in the picture here. It's not delegation flag 1, it's a delegation flag 0 because there is no subdelegation. It's just a regular report to inform about the path. So conclusion, so what we want to achieve is to enhance the current behavior, and we want to be able to have a very flexible design using PCEP. So I'm building my different PCEP clusters as I want, and I'm then try to share my computation, maybe by type of algorithm or type of optimization or whatever. But I really want to have something that is flexible in terms of placement. It may also address some problematic of scaling. If a PC is not able to handle 1,000 or 2,000 PCEP session, I will be able to share the PCEP session among multiple clusters. And the other point is that we want such mechanism to be deployed in a very fast way. So we did not really want to touch the PCC side, and we want to handle this really at the PC level. So we had some constraints also in terms of implementation. So we have some running code that we will be deployed in the coming months. So we are welcoming feedback from the working group on this proposal. Yeah, go ahead.
Daniele, I think this is a good solution for a problem that doesn't exist. in the sense that, so you're saying that the rationale behind this work is two reasons: resiliency and scaling.
And computation loop.
And? The
computation loop for this
the computation loop.
And I can prove that it can happen because it happened.
Okay. But my point is, in the case of resiliency, I wouldn't say that you need two PCE. What you need is a PCE with a good availability mechanism.
Yes, but okay, you are putting your availability at the application level rather than
exactly.
It's another design.
That's what is used for SDN controllers. So I don't know why it doesn't work for a PCE. You have a warm standby, hot standby, cold standby.
So maybe we can do this for BGP as well.
And for the scaling solution, I don't know, maybe you have already tested in your network, but in my opinion, before having scalability solutions at the PCE level, you might have more serious scalability solutions, for example, with IGP or whatever mechanism you use for routing, don't you?
It's not sure because it's sort of sometimes depending of how the implementation is done, but maintaining thousands of sessions is generally costly.
Yeah, but
We can see it with
you
BGP,
tend to
for
maintain thousands of sessions in a network with thousands of nodes and thousands of LSPs,
Yeah.
which means it's not just the PC that doesn't scale.
Yes, but IGP is scaling really more than that.
Huawei. I would like to ask a question for clarification about the master and the slave PCEs. About the role, is it permanent or as per RSP? So, for example,
It's flexible. It's flexible, so you can define a policy. So we don't, in the draft, we don't deal on how it is defined. But if you think the simple scenario of a manual configuration,
okay.
you can configure what you want. You can have a particular master for a set of LSP or set of association. You can do what you want.
If you fully rely on the manual configuration, there may be controversial.
I'm not saying that this is the best solution.
The last comment, please.
This is Adrian. Daniele is only right in the presence of unicorns. In the real world, this is a good solution for a real problem.
Thank you.
And yes, SDN has the same problem, which is why PCE is so wonderful.
I would say that SDN has more problems,
oh, well, yeah,
especially in
more
maintaining database and so on. It does not work on one network. There's a lot of issues.
So what I really want, what I really wanted to say was that the intention in PCE in PCEP as a protocol was that exactly bit for bit what you use between a PCC right down there, in other words, a router, and a PCE is exactly the same protocol as you use between a PCE and a PCE. And I think that possibly up to the 1 bit, the capability bit, is exactly what you have.
Yes.
And that just leads us to Hamian's question. You have to cope with the fact that a pair of PCEs may both attempt to delegate the LSPs in the opposite direction. And so you've got to have some resolution of that.
That's right.
Even if you don't have the configuration mechanisms in your draft, you have to have the, oh, what do we do? And some resolution, like the guy with the higher IP address wins.
That's right.
Just a very quick comment.
You can make a comment, but you're eating into your own slot.
Yeah, but I'll make the comment. The comment is very simple. Basically, the comment is that the solution that we come up with the protocol, or as we said, should be common. Like we can use PC to PC in hierarchy stateful. We are using PC to PC in interdomain, or now in this solution. So the protocol that we decide should be the same. And similarly, if we choose the sub-delegation, the mechanism of stateful HPC and this is sort of same. So maybe we'll work together to come up with the same set of protocol.
Fully agree.
Where are the blue sheets? We've got one up here. Does anyone have the other blue sheet? Anyone not signed the blue sheet yet? Okay, thanks. Can you pass that behind you? Thanks, Kohi.
Hi, this is Dhruv again, and this is the ability of stateful PCE to request and obtain control of an LSP. And these are some of my co-authors. Okay, so what's the idea? So far, what we do is we know that the PCC is the one who decides which PCE do you needs to delegate to. And in case something happens to one of the PCE, it is the role of the PCC to delegate control to a backup or another redundant PCE. But now we are coming up with some cases in which sometimes it's the set of PCEs which want to control that if something happens to me, which PCE should take control, especially in the clustering mechanism and some of the new ways in which we are doing PCE. We are running some mastership algorithm and other algorithm within our PCEs to decide which among us is the best PCE to take over when something happens here. The same thing also holds good when we want to do scalability. As the number of LSPs or the network is growing, I want to have one more instance of PCE joining this cluster. So I would like to move things around. And when I want to move things around, I want to do it at the PCE layer, the controller layer, rather than going to the devices and changing the delegation priority and preferences on each of the devices. So for this basic motivation. What we would like is a way for a PCE to request, oh, would you think about giving me control for this LSP? And of course, as per our stateful PC architecture, the final arbiter is still the PCC, and it is up to the PCC to honor this request or not. But we want a mechanism for PCE to at least request it. Another use case that some operators are asking, in which they would like the PCC to still retain control on the normal basis, but only when we do global optimization. And when I would like to change path by the PCE will request the PCC only for that time and then give up control back to the PCC. So this is another model that our architecture actually supports. To enable this, all we need is a mechanism for PCE to request this. So for these two cases, the idea is pretty straightforward. In the SRP object, we want to add one more flag, which is the LSP control request flag. And via this, in an update message, we can request that, oh, by the way, this LSP I actually don't control, but I would like to get control over this LSP. And it's a quite straightforward extension. And the final write, as I said, is still up to the PCC. But we need a small one flag mechanism to do that. Very quick questions. Do you think this is useful? It's no longer planned to be implemented because we did implement this during the hackathon, and works well on ONUS. And any comments? Anybody feels that this is useful?
Who has read the document?
Okay, there are people. Useful. Thank you.
Okay, handful.
Okay. Any comments?
Not from me. I think personally, not speaking as chair, but just personally, it looks like a useful function to have. It seems valuable for the controller to be able to request control. So.
A quick question, Hamid. How is this related with PC initiator work? Because it's also asked for the delegate. So any relationship?
No. So in case of PC initiated, you are creating a new LSP. This one is, I am aware of an spatially used. It's more useful for the PCC configured LSP, but of course it can be used for PC initiated LSP when it becomes orphan. The PC who actually created that LSP has gone orphan, and there is a backup PCE which wants to take control over that LSP. So again, this could be useful for both the case, but this will never be used to create a new LSP or to initiate a new LSP. The LSP already exists. I don't have a delegation for this LSP. You are requesting a PCC, can you delegate this to me so that I can make some changes?
Thanks, Drew.
Next one is okay, so next one is, this is the BIS document for RFC 6006, which was the extension for PCEP for P2MP LSP. So while working on the stateful P2MP draft and while implementing that, we noticed some of the issues with RFC 606. Nothing too big, but basically the things which are described in text maybe have missed in the RBNF. So we just wanted to clean up the document so that any future implementations, as well as the new work that we are doing, stateful P2MP, so that can be corrected and it doesn't have, like when we reference RFC 6006, it doesn't create any new confusions. So the main issues that we had were, for example, in the text, we talk about SWEC, we talk about that the PCEP P2MP request can be synchronized, but the actual RBNF doesn't have the SWEC object present. We also have some new objects which are defined in the document. For example, BNC, which is branch node capability, unreached destination. When some of the P2MP destinations which are unreached, you can identify them using a new object, unreached destination. And as well as we have the SRRO object, but unfortunately in RBNF, we have not put those objects. And also there is little bit some confusion where to encode the bandwidth object. While updating, we took care of all the erratas which were submitted on this document, and one of those was actually held for the document update. So let's look at it. So what are the changes? The first big changes, as I said, would be the SPEC list. So we did not have an SPEC before, but the actual document text talks about, as an example, that we can synchronize, and this is how the PCEP speakers should behave. So all the information related to SPEC is added. We also had an issue that we could only carry one request message. We do not have the request list, but that's very common with PCEP message. We do allow multiple requests to be carried within a message. So we made sure that we can do that. We had a new object called BNC for P2MP, but we did not have the BNC object in the RBNF. And we had 3 places bandwidth defined: bandwidth up here, bandwidth here, and bandwidth per RRO. So I think this was an issue because bandwidth would remain same for the set of leaves. So we tried to make sure that we have bandwidth present with the endpoint rather than per RRO. And we did not have SRRO. So we added the SRRO object as well. You can carry it with RRO or SRRO. Similarly, almost the same changes in reply, with one big difference that we also added: unreached destination, which is a new object defined in 6006. And again, SERO was there before as well. So rest all is the same. So question, is the BIS document needed? Especially for us when we are implementing stateful P2MP and we want to correct these things in stateful P2MP, we would like the BIS document to be there so that any future implementations and future authors will not face any issues. And any future work that we do in the P2MP, because this is our base document for P2MP, if we wanted to make sure that this is okay. Any other comments?
So, Dhruv, if I understood this right, the problem is the BNF, the RBNF is inconsistent with the text of the document, and you're updating the RBNF to make it consistent.
Yes, that's the main reason.
All right, so I'm thinking I'm kind of neutral on whether to handle this with a BIS RSC or as an errata on the RSC. I think the fact that it's the BNF does kind of make me think, but it is serious enough to want to flag this quite widely. But I don't know if Deborah has an opinion on how we would normally want to do it. But I mean, it seems like the original RSC is inconsistent, but at least the text is right. Yeah. So I guess it comes down to whether people are likely to pick that RFC up and just implement the RBNF without reading it, or if
the problem what we faced was the RBNF of the stateful P2MP. We don't want to carry on this, and if there is inconsistency, it's going to be just more problem future down the line.
I think coders would probably look more at the RBNF.
That's what I was
rather
wondering,
than
yeah.
at text, because it's harder to grasp. So I think it would be a good idea to spin the document.
Yeah.
Adrian, I did both.
both.
If you put the errata in now, Deborah can improve it 3 minutes later, and it's on record. And then it's still worth BISing this, and I would suggest that the working group can BIS it really fast. We don't even need to go through the adoption process. We've got the draft. You can do a working group last call on it pre-adopted, because it's such a small change, and put it on Deborah's publication list within 2 weeks of today.
Thank you. Action, Dhruv, to put that in the errata system.
Yep,
Thank you.
I'll do that.
I will introduce our consideration for PCEP extension for native IP use case. When we talk about traffic engine, this is the total graph for our current status. The traffic engineer mainly consider only the MPLS network, and there are several solutions, so MPLT and central control for such as the PCE and PCC SR, but there is no consideration for the native IP network. For native IP in the distribution consideration, we can only use the deep server solution for the traffic engineer. But for central control, we can use other solution. The key idea of PCE native IP is based on two concepts. The first is the dual multi-BGP system, and the second is the PCE-based central control architecture. This is the whole graph that I introduced in TIS group. I here just give a brief summary. To finish, accomplish the traffic engineer in native IP, we just need to do 3 steps. The first is built-in different BGP pair between the edge router, and the second is distribute the different prefix via the different BGP pairs. The third is centrally compute the path to the between the different BGP pairs. So to finish this, we need to do the PCAP extension for 3 objects. So here we define 3 new objects. The first is the peer address list object. It is carried in the PCE. Currently we consider it is carried in the PCE initial message. The receive peer should build the BGP relationship with the peers using the corresponding local peer IP address peer. The second is the peer prefix association object. It also carried in the PCE initial message. The receiving router should advertise the prefix via the corresponding BGP peers. The third is the explicit peer route object. It is used to appoint the PCC path to the explicit route to the BGP peers. So here we have some discussion. So at peers we have said that these objects can be piggybacked via the PCE initial message. Because these route information both initiated from the PCE and they have similar procedure for PCE and PCC, and the implementation consider mainly only the newly defined object, but there are other considerations. We can define the new message for mainly for the PCE native path. So if we define new message, we should define a new flag on the capability TLV. So I think that these are two solutions. We are just ask which solution is better. There are other discussions when we discuss with the Tencent company. They also have some consideration for the co-S parameter. So can we define some new object to transfer the co-S requirement on each link? So if we can transfer this object, we can reduce the congestion possibility of the short traffic. And we also consider this such a solution for the pure IGP network. It can be solved in the similar procedure. We use some such as the route tag solution to differentiate the traffic in the pure IGP network. So we welcome any comment for this consideration. Thank you.
Jessia from Huawei. Sorry, I didn't read very carefully your draft, but I have some question about for the. I think the use case maybe is helpful, but I have the confusing about the how the forwarding plane, the packet, how to the packet forward according to the your traffic engineering unification. As I know that perhaps one solution is you use source router source route option in IPv4, right? And another solution, maybe you can use the PC flow spec, like a BGP flow spec, that you can download some ACL to change the forwarding behavior. So perhaps I think PC flow spec has been proposed in PC working group. Perhaps you can use that PC flow spec to download the ACL. But I want to know what's your opinion about the forwarding plane?
The main point of our solution is we differentiate the BGP next hop and the route to the BGP next hop. So we need to change only for BGP next hop. We need to change only the action as the edge router. For the path to the BGP, we need to change only the router on the path. The difference between the BGP flow spec is that for BGP flow spec, we must send the different policy on every router for every prefix. But in our solution, the middle router only have the path to the BGP peer. We need not influence the route to the prefix. So I think the solution is similar for the layer 3 VPN, BGP layer 3 VPN, that only the PE router know the detailed prefix, and the PE router know only how to reach the PE router. So I think I have given one compare table in the TIS presentation, compare with the BGP flow spec and OpenFlow.
Are you assuming every node in this picture is running BGP? Because I don't understand how playing with the next hop is going to change any behavior, since they both exit through R7. Unless you're running BGP everywhere, and then you can have a next hop of R2 and different next hop of R3.
Yeah. We can build different BGP peers between the edge router and advertise the different prefix via the different BGP peers.
So there's multiple parallel peering sessions, if I've understood this correctly, with BGP, and you advertise some of the prefixes over one and some of the prefixes over the other. Yeah. So they acquire different next hop addresses. Yeah. Is that right?
Yeah, but you have to still have some kind of traffic engineering or something to force them on the other path, right? Because your IGP is going to converge to the same path for both.
No. The path to the BGP peer will be calculated and influenced by the PCE. So we will send the explicit route information, the third object.
So the PCE is creating a route to the BGP next hop.
Yeah.
Okay.
And you're going to use the IPv4 explicit path?
IPv4 IPCC is
that,
native one.
Not too many people do that anymore. It tends to slow routers down a whole lot, so you just don't.
I think if there is no the central control for IP network there, it is very difficult to influence the traffic in the native IP. But if you have the PC located in network, we can influence the next hop between the path to a BGP next hop very easily.
Mm-hmm. So I think there are two discussions here. One is, how does this work at the network architecture level, and is that a good way to go forward? And then the other one is, what would happen in this working group, which is, if we agree on that, then what are the PCEP extensions required to support it? Now, I know that other discussion is happening in TEAS, and you have a draft in T. So what I'd like to suggest is that we need to see that discussion advance
No problem.
within T's, and then we can bring it back here if it's if it looks like T's has approved that, then we can bring it in
Okay,
here.
I know.
And
I
think about-
think you should run it by RDR as well to make sure you're not violating any policy decisions that would have been made solely by BGP.
That's the IDR working group. Okay, thank you.
Hi, everyone. So this draft was presented in last IETF, and also we have discussions on the list. So some people says that nothing new in this draft. Some people says that this may simplify the operation. So today I'm going to present some facts and then have discussions. So factor one, less configuration, so simple operation. So right now for Internet AS link, we already have OSPF extension for that, ISS extensions for that, BGP LS extension for that. But those extensions need more configuration. For example, we need for OSPF, we need to configure ACE number, remote route ID, and then we also need to configure the adjacencies between OSPF and the PCEs. After we have those adjacencies formed, PCE can get information about inter-AS link. So for BGP, BGP-LS is dependent on OSPF. So for some link at least, we also need to configure adjacency between BGP and the PCE. So after this adjacency formed, PCE can get information about inter-domain link. So this is the facts. Then for our draft, no need for these configurations. So another facts. So new to BGP-LS. So we know we have ABR. ABR connects two domains. ABR connects area to backbone area. So this ABR, so child PCE need to send this ABR to parent PCE. So here we propose, what's going on? So we propose use notification match, just ABR from this PC to parent PC, and then from this PC to parent PC. So after receiving this information, parent PC can build these connections between domains areas. So this is new, and then we don't have things in the BGP-LS. And also access point. So this is also new. So another thing is new to the BGP-LS is abstraction. So abstraction, there are many ways to abstract topology from parent PC to from child PC to parent PC. So why is that parent PC and child PC, they are in same organization? So in this case, child PC can send everything to parent PC, the whole topology, inside out. So second, and then maybe they're not friends. So we need to hide the information inside the topology. So in this case, we have a number of ways to do the abstraction. For example, for this domain, we can just have a full mass of edge links, edge routers to parent PC. We can have just consider this domain as a cloud, and then we just send the inter-domain links to parent PC, and then we can have another abstractions. So this is second case. The third case is that the child PC is also a parent PC. So in this case, we also have a number of ways to abstract the topology, because in this case, this child PC has a number of domains under it. So we can have, for example, this domain, all under this child PC. So one way is that for all these domains, we can abstract as this way. So we can consider all these domains as a cloud, and then we just send the inter-domain links to the other domains to the parent PC. We can also maybe another way is that we can do abstract in this way. So in summary, I presented these facts. That's configuration. So that's operation. New to BGP-LS or the other things. ABR as domain connection, access point, and abstractions. So any questions or discussions?
So is this, you've finished the slides?
Oh, yeah. Finish
Okay.
the main slides. And then I have backup slides.
Okay,
And then
cool.
if people asking, oh, this is non-civil, I can present. So what's inside of the BGP-LS? And then we can discuss from there.
Yeah. I mean, is this what you've implemented? Have you got code that's doing this right now?
For the implementation?
Yeah.
No, not right now. Maybe. We will do the implementation. Yeah.
Okay. Yeah, and I know there was some discussion on the list of this draft, and it didn't really resolve on the list, so I was hoping that we could try and conclude that discussion now. We have a few minutes.
Dhruv from Huawei. We have implemented this via PCEP-LS, and which is trying to do the same functionality. But I think the authors may not like that idea. They feel that the idea is too big. But I hope that within PCEP protocol, we can at least write the protocol in a generic way that when we are sending a node, whether it is a node, ABR, ASBR, it's just a node, and we can encode this as a node. Similarly, a link is a link, whether it is an abstract link, inter-domain link. We want to propose a simple extension similar to BGP-LS that will work in all cases, rather than a very specific sending a notification only for ABR, another notification for ASBR, which I feel is like, it solves your problem. Definitely, we agree on the use case. Both of us are proposing the same thing. This is aligned to ACTN as well, aligned to stateful HPC. It's just the protocol part that we disagree on, that whether we should do it via notification or whether we should do it by a generic mechanism like PCEP-LS. We have few more drafts on PCEP-LS. Maybe we can discuss this a little bit more in detail then. Thank you.
My understanding that we have BGP-LS, and then we have PCE-LS. So PCE-LS, my understanding is that is a conversion from BGP-LS. So you can think, so that is the way I'm thinking. Also, so if you have any interest, and then go deep into those PCE-LS to see whether it's converted from BGP-LS.
Okay, thank you. If anyone else has any interest in this, then please make your interest known on the list. Next up is Young.
Yeah, this is PCAP extension for PCAP-LS for optical. Let me highlight just the last point. This is kind of related work since the time is limited. PCAP-LS has been proposed quite a few in the last meetings. Basically, it's a generic mechanism that allow link state and T information to be collected from packet networks or general networks and share with the PC with PCAP itself. I think that the motivation for this work is basically we have three cases where IGP is running in optical networks, but there is a need for faster link state and T resource collection at the PC directly from optical node. That's one motivation. And another motivation is case two, where there's no IGP running in optical networks and there's need for link state and T resource collection. And case three is there is need for transporting abstract optical link state and T information in hierarchical PC setting and also ACTN setting. So these are the three main use cases for this particular extension. Yeah, we basically, this node TL, attribute TLB is one of link state object attribute. And then we are basically enhancing optical related TLV so that PCAP-LS can be applied for optical networks. Likewise, link attribute TLB, we added ISCD and OTN and WSAN and flex grid related information and put wavelengths restriction to cover all the optical work that has been placed in this working group. So as Drew mentioned, this link or node, we don't necessarily differentiate whether it's inter LS link or just a typical link. So I think what Huaymo said can be covered with this draft. Just the implementation report. Both packet-oriented PCAP-LS and optical PCAP-LS actually have been implemented, will be demonstrated in the bits and bytes interoperability test tomorrow. So if you can stop by, you can see some portion of what we have implemented. I think next step, I think PCAP-LS has been discussed quite a bit in this working group multiple times, and as I said, implementation exists. So I just would like to ask working group chairs to consider if this work is interested item in this working group and move forward.
Thanks, Young. So it's true, PCAP-LS has been discussed several times, and I have to say to this point, I haven't heard a whole lot of support for it outside of the authors of PCAP-LS. And I know some people don't think it's a great idea, particularly as it's basically re-implementing BGP-LS. I have my own personal opinions about that, not as chair, but I thought this would be a good chance to ask the working group if that attitude has changed at all. If anyone really wants to see PCAP-LS become an IETF standard, or if we're still in the position of it being a controversial idea. So if you're for it or against it, please stand up and go to the mic. And so either no one understood my question or actually no one cares apart from Young.
Yeah, I think BGP-LS is only for the packet networks, as you know. Optical, we don't have BGP-LS implemented in IETF, as you know. And also this is an incremental update, which BGP-LS has, it depends on TLSA convergence, which OSPF provides. So this is much faster. That's one of the points that we would like to demonstrate in the BNB.
Yeah, Haomian from Huawei. Maybe I need to clarify. We need to clarify first who is PCAP-LS to compete with. If BGP, I think it's just like Yang said. Many people ask for IP and optical together, but unfortunately, optical do not have BGP one. If it compete with others, we need to further analysis on the difference and get this conclusion. But now we think PCAP LS is at least essential for optical section. And we hope it can be generic and also used by
So
IP
is the
network.
problem with BGPLS that it doesn't support optical TLVs, or is it that the devices you have deployed in optical networks do not have a BGP stack running on them?
Both.
It's both.
Both, yes. And there's no active work in BGPLS either. Any optical extension or adding that TLV.
Yeah, well, you could fix that, but I guess it's harder to fix the deployment problem.
Correct, exactly.
Yeah, it's Adrian. Yeah, I mean, putting TLVs into one protocol or another is not a lever, because, you know, if we put it in BGPLS already, would you be saying, no, let's not do it in PCEP? No, I think you'd still be wanting it in PCEP. So your motivation here is not whether or not it already exists in BGPLS.
Yeah.
Your motivation is what do you need to build and deploy? And that's a harder question. And I don't think we should have that conversation without also saying netconf. And we seem to have this three-way beauty contest for a number of things now. And I think probably the only way to resolve that is to understand what people want to build and operate and where we need interop defined.
Okay, so that sounds like a longer discussion than we have time for now. I think I'll start a thread on the PCE mailing list to continue that discussion.
Okay.
Thank you, Liam. So the final presentation goes to Justin.
Hello, this is Jia Fan, come from Huawei. The draft is PCP link state extension for segment routing. What's new in version 01 is there's no difference because the 00 version draft has already updated 1 year ago, but we have not presented. So this is our first time to present. And this draft purpose is in order to fulfill the need of for applications that require visibility of SR paths across IGP areas or even ASs. This draft define extensions for the mechanism introduced in PCAP-LS to propagate SR information in those scenarios that have no IGP SR extension or BGP-LS running. So what's BCP-LS? Let's make a simple introduction. It's only PCAP-LS is just collect the link state information and TDB information, find the PCCs and send them to via PCAP protocol to PCs to compute the path. And this is a simple introduction to segment routing. It's just encoding path as sequence of topological subpaths. Okay. So these are problems. If SR paths need to across BGP areas or across IGP areas, especially in some optical network, but I have no BGP areas running. So what we should do to view all segment routing paths? We have already discussed the previous draft by Yang Li. Okay, this is the same question. So we import new additional TLVs in LS report messages, which is defined in P7 LS new message, and we import seven TLVs, and the 6 of them had already defined in IGP segment routing extensions, and the 6th one is defined in tunnel segment routing extensions. So this one. So that's all.
Any questions or comments? Okay. Okay, thanks, Justin.
Thank you.
And that's it, everyone. Thanks very much for a good meeting, and we will see you next time.
No bloodletting.
Talking like fury through the whole thing.
Yeah, it's good. No, we've got the minutes actually. Yeah, just have a scan through and update anything. Hopefully, it's something I'll be really straightforward. So. And the guys really help as well. I'll drop these in at the secretariat desk.
Yeah, thanks a lot. What do you think of FIFA Plus? Am I missing something? Well, every time I try and figure out how to implement it for software architecture,
Yeah.
as on the one hand,
BGP LS for some of the additional specifications. Same with Postman as well.